Good afternoon, friends. Today we shall be discussing about parts of network functions. Now, before we go to that, I will just briefly summarize what we did yesterday in the Bode-Duffin synthesis, then we will go to parts of network functions. So, in the Bode-Duffin synthesis, we defined the Richard function, which is a positive real function in terms of Zs as kzk minus szs. If Zs is a positive real function, then for all positive values of k, Rs will also be a positive real function. From there, we wrote Zs in terms of Rs as kzk Rs plus szk divided by k plus srs, and this we broke up in this form. If you remember, in the form of two parallel elements put in series with another set of this type, k by s zk plus rs by zk. Okay. So, this was shown to be like this. This is the admittance of a capacitor. Is that all right? So, this is admittance of a capacitor. So, 1 by kzk farads will be the value of this capacitance. This is, say, this is some Z1, then in parallel with this capacitor, this impedance Z1 will come. Similarly, this one is the admittance of a reactor whose value is Zk by K, so many inductance. In parallel with that, you have Z2, which means Zk by Rs. Is that all right? So, this is what we wrote yesterday. Now, Z1 to be calculated, Z1 is Zk into Rs. Rs being a positive real function, Zk is having a constant value for a particular value of k, real value. So, this is an impedance function, realizable impedance function. Similarly, Zk by Rs is the other impedance function. You can see one is Zk into Rs, the other one is Zk by Rs. We started off with this point. If at a particular omega the real part is 0, real z j omega 1 equal to 0, then z j omega 1 will be just some reactive element. It may be plus jx1 or minus jx1. Suppose it is plus jx1. If it is plus jx1, it will be inductive. Now, I can have this at omega 1. Suppose at omega 1 this is 0, this is 0 impedance. That means at omega 1 Zk into Rs is 0. Okay. Then the current will flow through this, and then Z2 is Zk by Rs. If Rs is having a 0 at omega 1, then 1 by Rs will be having a pole. So, if this is 0 impedance, then this will be infinite impedance. So, the current will be made to pass through this short circuit, 0 impedance, and then going through this, because this is open circuit. So, it will be appearing to be this inductance. So, Zk by K, we started off with Zk by K is equal to x1. This was our starting point. So x1 has been evaluated for the given ZS. We found out the frequency, where this real part is 0. Okay, we determine the frequency. At that frequency, what is this one? We calculated this was jx1. So this x1 will be coming out of, mind you, x1 represents the reactance. So x1 by omega is the inductance, that is equal to zk by k. Okay, x1 by omega we calculate that as this inductance L. Okay, that is zk by k. So from x1 you calculate L, which is x1 by omega 1, and that is equated to zk by k. So calculate k. Okay, once you know the value of k, L is known, k is known, so zk is also known. Substitute here, you get zk into rs. See, if I put the value of k here, I get rs. Zs is given, I get rs. All right, and we saw yesterday rs is having 0 at omega 1. Okay, and z2 was infinity. Whenever there is a pole, how do you realize it? Make partial fractions. So we made a partial fraction and then we got z2, this impedance. Similarly, we inverted z1 and got the values of these impedances in the form of two admittances. So the values that we got, I'll just show you the final values that we got yesterday. It was like this. The structure came like this. There was a capacitor and you had R and LC in series, combination of R and LC in this mode, two parallel elements in parallel with C1. So this was equal to Z1. This is Z1. Similarly, this was Z2. Okay. If you have, instead of plus jx1 at that particular frequency omega 1, when the real part vanishes, suppose z is having a minus jx value, it can be plus jx or minus jx. Suppose it is minus jx1, then we would like to, this is capacitive at that frequency, so you would like to equate it to this capacitive impedance. That means as if the current is made to flow through this, so this is an open circuit. All right, so Z1, which is Zk into Rs, should have a pole here at omega 1, and automatically this will have a 0. So the current will flow like this and then through this short circuited path. Okay, so Zk into Rs will be equal to 0 at that particular frequency omega 1. Zs Rs is having a 0, means you have to equate this to 0 at that frequency omega 1. So you can calculate the value of k. Okay. Z1 is infinity, sorry, Z1 is infinity. So the denominator should be 0. K into Zk should be S into Zs at S equal to j omega 1. So it is this denominator which has to be equated to 0, and then you determine the value of k. Rest of the thing is simple, straightforward. Now we take up this topic, parts of network function. We shall come back to some numerical problems at a later stage. Sometimes for this function we may be given just the real part or the imaginary part. The variation of this with respect to frequency is specified, or variation of this with respect to frequency is specified. Can you realize Z? Or sometimes it may be written Z magnitude, which is a frequency dependent quantity, and e to the power j theta, which is again frequency dependent. Either this magnitude or the phase will be given to you. Can you find out Z? That means from the real part, can you realize the imaginary part, and hence the total function? Or from the magnitude, can you estimate the phase, and hence the overall function? You can realize it under certain conditions. For example, suppose you are having a simple RL network. Okay. Now, suppose you are given the imaginary part. Imaginary part is j omega L. Okay. Now, it can have a real part which can be either R or R1 plus R. So, from Z, if I am given only x omega, that is imaginary part of Z, then the real part can be R omega or this plus R dashed. Any additional resistance I can put, but still, because this is not specified, it can be anything. So, I can realize this only when it is having the minimum value, that is just what is required to realize ZS, whatever R omega is required. Okay. So, it is not possible to determine R omega under any condition. There can be hundreds of solutions for a given x omega. If the imaginary part is specified, from there I can find out only one unique value of R under certain conditions. It is a minimum resistance function. Similarly, for the other one, if R omega is specified, you can find out x omega only under minimum inductance condition. Otherwise, I can keep on putting some more inductance, still R omega will not be disturbed, is it not? So, we shall be determining only those minimum reactance or minimum resistance required to realize that function. Now, suppose you are given the real part given. How do you realize ZS? Let us take a very simple case. If R omega is given, what will be ZS? Now, R omega is basically even ZS when I put S equal to j omega, is it not? If you remember, even part of ZS, so ZS can be written as even part plus odd part, even part plus odd part. M1, M2 are the even parts, N1, N2 are the odd parts. This we discussed while testing the positive realness of a function, if you remember. So, this can be written, if I try to find out the even part and the odd part separately, then it will be M1 plus N1 into M2 minus N2 divided by M2 squared minus N2 squared. I have just multiplied by sorry, M2 minus N2 both sides. So, I have got M1 N1 plus M2 minus N2, M2 square minus N2 square. That gives me M1 M2 minus N1 N2, this is the even part, plus N1 M2 minus M1 N2 odd part divided by M2 square minus N2 square. If you remember, we discussed this point, M2 plus N2 into M2 minus N2 will be always a mod is it not? Suppose m2 plus n2 at s equal to j omega, suppose this is a plus jb, then what will be m2 minus n2? It will be a minus jb, is it not? Even part m2 plus n2, so even part will give you real part, odd part will give you imaginary part, and it is the odd part whose sign is changed, so it is going to be minus jb. If I multiply this, you will get a plus jb into a minus jb. Alright, that will be m2 square minus n2 square, which is nothing but a squared plus b squared. So this is a positive quantity. So this is a positive quantity always for all values of s equal to j omega. Therefore, this is even into even, this is odd into odd, so this is the even part and this is the odd part. Alright. So our starting point will be this m2 squared minus n2 squared. So m2 squared minus n2 squared, it is a function of omega squared. See, odd function squared will be even, so it will be something like omega, omega cubed and so on. If I square it, you will get all omega squared, omega 4, all even powers of omega. Similarly this one, so this will be something like a function of omega squared. S equal to j omega means s squared is equal to minus omega squared. So in this, if I put omega squared is equal to minus s squared, I will get m2s minus n2 square s, is it not? Will be p minus s square. Is that clear? I will take an example and show you. Suppose I have 1 plus s squared plus 2 s to the power 4. If I put s equal to j omega, what do you get? 1 minus omega squared plus 2 into omega to the power 4. Suppose you are given this function, how do I get back to this? Put omega squared is equal to, just reverse substitution, omega squared is equal to minus s squared. So that gives me 1 plus s squared plus twice s to the power 4, is it not? So that is what precisely I have done. m2 squared minus n2 squared is given in terms of omega square. So make a substitution omega square equal to minus s squared, alright, that will give you m2 square s minus n2 square s in the s domain, alright, and that is nothing but m1s plus, sorry, m2s plus n2s into m2s minus n2s. Okay. Now you see m2s plus n2s, suppose this is having roots like this, then what will be the roots of m2s minus n2s? m2s minus n2s, it is the odd part which is negated, odd part of a polynomial which is negated. So if you are having a polynomial containing roots in the left half plane, then if I take just the negative sign of the odd terms and generate another polynomial, then that will have roots in the right half plane, just the mirror images. This is something very interesting. You have fx equal to 0, alright, which is a function of say a1x even parts plus a2x odd parts, then f1x which is given by a1x minus a2x equal to 0, this will have roots which will be mirror images of this. If this is having roots in the left half plane, fx is having roots in the left half plane, then f1x will have roots in the right half plane, where f1x is having the even part as it is and odd part with a negative sign. Is that all right? So for any complex pair of roots, for example, if you have a complex pair like this, for m1 plus m2 plus n2, one pair of roots is like this, then for m2 minus n2 correspondingly you have roots here, mirror images. So you get quad of points. For each complex root set you get actually quad of points for the function m2 squared minus n2 squared. Okay. So problem is simplified. You are given m2 squared minus n2 squared in terms of omega. So make a substitution, omega squared is equal to minus a squared, then factorize it, then choose the factors corresponding to the left half plane roots. That will give you m2s plus n2s. Why left half plane roots? Because original function zs is a positive real function which should satisfy Rautharovitz criteria. That means all the roots of the numerator and the denominator must lie in the left half plane. So m2s plus n2s corresponds to the function zs. It is the denominator of zs, is it not? Which is a realizable function. So the roots here are lying in the left half plane. So you select out the roots corresponding to the left half plane. Once you have done that, then m2s plus n2s is defined. m2s plus n2s is selected. Now you choose zs equal to, suppose this is equal to some b0 plus b1s plus b2s square. Suppose it is like this. Maybe b0 s to the power 3, b0 plus b1s plus b2s square plus b3 s to the power 3. Then what will be the numerator like? It can have a0 plus a1s plus a2s squared plus a3s cubed. Okay. Any question? The condition for a positive real function is the power of s should differ at the most by 1. Can I take a4 s to the power 4? See, by division there will be a free s term. That means some reactance element, additive reactance element will come. It can be anything. That becomes indeterminate. Is it not? As I was telling you right in the beginning, I can identify from that only x corresponding to the minimum value. Any additional x will also give me the same real part. Real part remains unchanged if you keep on adding reactances. So we will consider only that reactance function which is just required to realize zs. So we will not go further beyond this. S to the power 4 by s to the power 3 will give me by division one free s term, something like an inductor, a free inductor, and that can have any coefficient a4, a5, a6, it can have anything. So we will take this as zs, and then what will be a real part of zs? What is the even part of zs? From here you take m1 m2 minus n1 n2, okay. So that means a0 plus a2 s squared into b0 plus b2 s square minus the odd part product. Put s equal to j omega. That should correspond to the numerator of the given real function. We have started off with the denominator m2 square minus n2 square of the denominator. Now you equate this to the numerator given. Let us take an example, it will be clear. Okay. A simple example we shall take, say suppose the real part r omega is given as 1 by 1 plus omega to the power 6, 1 plus omega to the power 6. Then m2 squared minus n2 square at s equal to j omega, that is given as 1 plus omega to the power 6. So you make a substitution, omega square is equal to minus s square. So how much will it be? 1 minus s to the power 6. Okay. 1 minus s to the power 6, if I factorize s to the power 6 equal to 1, okay, then s will be 1 e to the power j 2 pi m by 6. Okay. M is an integer. So the values are m is equal to 0 means this one, so this is a unity circle, this is one root, m is equal to 2 means 2 pi by 6, m is equal to 3, this one, 4, 5, 6 with a spacing of 60 degrees, and these are the 3 roots lying in the left upline. So these 3 will contribute to m2 plus n2. Okay. So m2 plus n2 straight away you can write, how much is it? This is 1, this is 120 degrees. So s plus 1 factor corresponding to this is s plus 1, factor corresponding to this will be s, this is minus 0.5 cos 60, so s plus 0.5 plus this is j 0.866 minus j 0.866, so one is plus j 0.866 and s plus minus j 0.866. Is that all right? So that gives me s plus 1 into s plus this alpha plus j beta and alpha minus j beta. If I multiply, it will be alpha square plus beta square, which is 1. So s squared plus 1 plus 2 into real part, which is 0.5, 2 into 0.5 is 1 into s. Is that all right? If these are alpha and j beta, then when you form a polynomial corresponding to this pair, you will get s squared plus 2 into alpha s plus alpha squared plus beta square. This will be the factor corresponding to one pair of roots, and if the roots are on the unity circle, then alpha square plus beta square is 1. Okay, this is alpha, this is beta. So 2 into alpha here is 0.5, so 2 into 0.5, that gives me 1 into s plus 1. So this is my denominator polynomial, m2 plus n2. Is that all right? So let us write this as s to the power 3. Is that okay? S to the power 3 plus s squared twice s squared plus 2s plus 1. So, and what is the numerator of this? 1. Okay. So we shall write zs as a polynomial, sum a0 plus a1s plus a2s squared plus a3s cubed divided by 1 plus 2s plus 2s squared plus s cubed. I just put in reverse order, it can be, I mean that is immaterial, you can put in any order. Okay. So this is the denominator. Once you have determined the denominator, you assume a polynomial for the numerator. Then what will be m1 m2 minus n1 n2? At s equal to j omega, it will be the even part, m1 is a0 plus a2s squared into 1 plus 2s squared minus a1s plus a3s cubed, is it all right, into 2s plus s cubed at s equal to j omega. Is that okay? So that gives me, let us simplify this, a0 plus twice a2, sorry, plus a2 plus twice a0 into s squared plus twice a2 s to the power 4 minus twice a1 s squared, okay, minus a1 s to the power 4 minus twice a3 s to the power 4 minus a3 s to the power 6. Okay, you may put s equal to j omega, so that gives me a0 plus minus a2 plus twice a0 minus twice a1 into omega squared plus twice a2 s to the power 4 minus a1 minus twice a3 omega raised to the power 4 minus and minus plus a3 omega to the power 6. Is that okay? And that was equal to 1. Numerator was given as 1, omega square coefficient is 0, omega to the power 4 is 0, omega to the power 6 is 0. So we will equate each of these coefficients. So coefficient wise, if we go, last one is omega to the power 6 a3. What is the coefficient here? Is 0. All right. So a3 is 0. Then twice a2 minus a1 minus twice a3 is 0, which means a3 is already 0. So twice a2 minus a1 is 0. Next, a2 plus twice a0 minus twice a1 is 0, coefficient of omega square, that is also 0. Okay, and then lastly a0, and that is equal to 1. a0 is equal to 1. So if I substitute here, I will get a2 plus 2 minus twice a1 equal to 0. Okay, from here I get a1 equal to twice a2, is it not? a1 is equal to twice a2. Substitute in this one, that gives me a2 plus 2 minus twice a1 means minus 4a2 equal to 0, or a2 is equal to 2 by 3. Substitute here, a1 is 2 into a2, so 4 by 3. So the coefficients are, therefore numerator, I will straight away substitute these values. a0 is this, a2 is this, and a1 is this. So how much is zs? Zs will be therefore a0 1 plus a1s, that is 4 by 3 s, plus a2s squared 2 by 3 s squared, divided by the numerator is this and the denominator is 1 plus 2s plus 2s squared plus s cubed. Is this all right? So we started off with the denominator polynomial, made a substitution of omega squared is equal to minus s squared, got the roots of the total set, that was m2 square minus n2 square. Then find out all the roots, take the roots of left half plane, form the polynomials, write in the polynomial form, and then assume a numerator of maximum power of the denominator. Okay. Then find out the numerator of the even part from this relation m1 m2 minus n1 n2. Put s equal to j omega and equate with the given function r omega. So that should be equated to 1. So if you equate now the coefficients, you get all these values, okay, coefficients of omega square. If you equate, then you get simple linear relations in terms of these constants a0, a1, a2. So after that you frame the polynomial. So this is Zs. A3 was found to be 0. Is this all right? Had I had 1 plus omega squared, let us take the same example, let us see whether it is possible, to have r omega equal to 1 plus omega square by 1 plus omega to the power 6. Is it possible to have this function? And if it is so, what will be? Okay, let us have this 1 plus omega squared. Then this will give me the same polynomial, all right. So I'll write Zs equal to 1 plus 2s plus 2s squared plus s cubed. We know if I have a factor of 1 plus omega to the power 6 as m2 square minus n2 square, corresponding m2 plus n2 polynomial is this, taking only the left half plane roots, okay. And the numerator, let us assume a0 plus a1s plus a2s square plus a3s to the power 3. Now after all this, we got m1 m2 minus n1 n2 as this, so we shall be using this. A0 minus A2 plus twice A0 minus twice A1 omega square plus twice A2 minus A1 minus twice A3 into omega to the power 4 plus A3 into omega to the power 6. Okay, this was our numerator, is it not? M1 M2 minus N1 N2, starting with this. Now that has to be equated to 1 plus omega squared now. So A0 is 1, then this one, this is minus, so if I reverse this, twice A1 minus twice A0 minus A2 is equal to 1, coefficient of omega squared, okay, coefficient of omega square is 1, so I am equating this to 1. Then this one is 0, twice A2 minus A1 minus twice A3 equal to 1, and A3 is 0. Is that all right? So if I put a0 equal to 1, what do I get here? Omega 4, yes, sorry, it is 0, yes, it is 0. So a3 is also 0. So from here, if I substitute here a0, what do I get? Twice a1 minus 2 minus 2 minus a2 minus 2. If I bring it to this side, that will become equal to 3. Okay, and twice a3 is 0, so twice a2 minus a1 is 0. Okay, that means a1 is equal to twice a2. a1 is equal to twice a2. If I substitute here twice a1 means 4a2 minus a2 is equal to 3, or a2 is equal to 1. Is that all right? a2 is equal to 1 and a1 is equal to 2 into a2, so 2. So what will be the polynomial now? It will be Zs will be 1 plus twice s plus a2 is 1 s squared divided by 1 plus 2s plus 2s squared plus s cube. Is it all right? Parts of network functions I have not yet tested. I have not yet tested whether this is a positive real function or not. What we have checked is, given the real part, construct the total function. All right. Given the real part, form the total function. So this is basically 1 plus s whole squared. Is it not? 1 plus 2s plus s squared. 1 plus s whole squared divided by these 3 roots. So you are having a pole zero distribution like this. These are the 2 zeros. Now you see something very interesting. Can you tell me what? This is 1 plus 2s and this is also 1 plus s is common, no? This is what? 1 plus s. If I remember, this polynomial was coming out of these 3 roots. Is not? So s plus 1 into s square plus s plus 1, and then pole zero cancellation. Basically it is 1 plus s by 1 plus s plus s squared. Will you get this? 1 plus omega square by, basically 1 plus omega square is a factor here, no? One plus x cubed is 1 plus x into 1 minus x plus x square. Is it not? So this will go. So basically what I gave you is okay. So even if you have forgotten to cancel it here, it is reflected in this. 1 plus s is a common factor, pole zero cancellation. Basically this is the function, and if you take the real part, you will get this. It is same as this, no? If I have, there is a function given, real omega is equal to omega squared by 1 plus omega squared into 4 plus omega square. 1 plus omega square into 4 plus omega square. So what do I do? Put omega square is equal to minus s squared, alright, for the denominator. Then that will give you m2 square minus n2 square. So 1 minus s square into 4 minus s square, alright. So this is 1 plus s into 1 minus s, and this is 2 plus s into 2 minus s, is it not? So there are roots here at minus 1, minus 2, plus 1, plus 2. So m2 plus n2 I will select as the left half plane roots 1 plus s and 2 plus s, is it not? So that is s squared plus 3s plus 2. Is that all right? So what will be the function zs like? The general term will be a0 plus a1s plus a2s square divided by 2 plus 3s plus s squared. Alright. So what will be the real part? m1 m2 minus n1 n2 s squared plus 2 into a2 s squared plus a naught minus 3 into a1 into s square. That gives me a2 into s to the power 4 plus twice a2 plus a naught minus thrice a1 into s squared plus twice a naught. If I put s equal to j omega, so m1 m2 minus n1 n2 at s equal to j omega will be a2 omega to the power 4 plus minus twice a2 plus a0 minus thrice a1 into omega squared plus twice a0, and that has to be equated to omega squared. So a2 is, what is the coefficient of omega to the power 4? 0. So a2 is 0, okay, and with a negative sign this is equal to 1. So if I put the negative sign inside, thrice a1 minus a0 minus twice a2 is equal to 1, and a2 is 0, so that gives me thrice a1 minus a0 equal to 1, alright. And then next, twice a0 is how much? Twice a0 is 0, so a0 is 0. So what does it mean? a1 is 1/3, okay, a1 is 1/3. It's very interesting, only one of them is present. Now let us see what kind of function it is. a1 is equal to 1/3, so zs is 1/3 s divided by 2 plus 3s plus s squared. Can you realize it? Is it a realizable function? There is nothing here, nothing there, only one term, and here it is a quadratic. What is 1 by zs? That is ys. If you invert it, it will be 2 plus 3s plus s square into 3 by s, is it not? So 6 by s plus 9 plus 3s. So this is an admittance of what? 1/6 Henry. This is 1 by 9 farad, 1 by 9 ohms, and this is 3 farads. So this is basically the network. is it not? So don't get frightened even if there is a single term here and there are 3 terms here, because it is in the center. So if I just divide, I will get basically RLC, I will get ZS. Is that okay? So given the real part of the function, you can calculate the overall function ZS, and in that process we have already calculated x also, because once you know ZS, all these coefficients, then what will be x omega? If I ask you to calculate the imaginary part, what do you do? Directly put s equal to j omega, take out the imaginary part, or otherwise m1 n2, the odd part, minus n1 m2, okay, this part divided by m2 square minus n2 square. M2 square minus n2 square is already known, that is 1 plus omega to the power 6 and so on, like that. So it is this part which has to be computed, okay, from that a0 a1. Alright, in terms of a0 a1 a2 you can calculate this and substitute. Once you have calculated these coefficients, just substitute there, you will get the odd part. Otherwise in ZS put s equal to j omega, take out the real part and the imaginary part, that will be giving you x, okay. So we will stop here for today. We will take up a few more problems in the next class along with problems of RLC synthesis. Thank you very much. Good morning friends, we shall continue with the topic on parts of network functions. Yesterday we discussed about functions R omega being given, how to get ZS, okay. So we resolved this by substituting omega square equal to minus s squared. We took the roots in the left half plane and finally found out the coefficient of the numerator a0, a1 and so on. Now today we shall be discussing about the magnitude function. If the magnitude function is given, how to calculate phase. Magnitude function is given to calculate, to determine phase. Now the magnitude z squared can be written as zs into z minus s at s equal to j omega. Is that all right? And what is zs? If I write in terms of even and odd parts, m1 plus n1 by m2 plus n2, this is zs. And what is z minus s? m1 minus n1, it is only the odd part which will be having a negative sign now, divided by m2 minus n2. Is that all right? At s equal to j omega. So what you are getting is m1 squared minus n1 squared by m2 squared minus n2 squared at s equal to j omega. Is that all right? So if you are given z magnitude squared, it is basically m1 squared minus n1 square by m2 square minus n2 square at s equal to j omega. So if I make a reverse substitution, I will get m1 square s minus n1 square s by m2 square s minus n2 square s from here, okay. So there if I factorize and drop out the roots in the right half plane, I will get m1 plus n1 and correspondingly m2 plus n2. It is very simple. So let us take one example. Z j omega squared is equal to 1 plus omega squared by 1 plus omega squared plus omega to the power 4, any finite roots, that is zeros. So, 1 by 1 plus s whole cubed. Is it all right? So, this is not a driving point impedance, it is an impedance function, it is a transfer impedance function. In case of a transfer impedance function, you may have difference in the degree more than 1, but in case of a driving point impedance or admittance function, we know the difference in the degree should be restricted to 1. Here you can have more than 1. So, this is not a driving point function.
So, why it is so, the difference is 1 and the difference is greater than 1?
Not greater than 1, it may or may not be 1.
For the not having a
So, transfer function is a ratio between two voltages, say, or voltage and current. So, that transfer function can be anything. It can have only thing, the roots must be in the left up plane, that is poles must be in the left up plane. So, yes, this is a neat stable system. 4 into s square plus 8, s into s square plus 8 divided by 2 into s square plus 2s plus 4. By the way, why did I take s square plus 8 as a factor? If you remember in the network, this function Zs is having a value minus half root 2j at that frequency, all right, and it is also the value of this that we have equated. So, this will be a 0 at that frequency. If you remember, this element Z1s must be 0 at that particular frequency, omega 1. Okay. So, this Z1s at omega 1, that is 2 root 2, that is s square plus omega 1 square will be a factor in the numerator, and omega 1 square is 8. So, s square plus 8 will be a factor, that we know.
So, this is, please explain that part.
Because what we try to ensure is this impedance at that frequency is equal to the reactance at that frequency of this coil. So, what will be the impedance of this? It has to be 0, because this impedance is equal to this impedance. So, this has to be 0. So, Z1s must have a 0 at that frequency. So, s square plus 8 must be having a numerator factor, must be a numerator factor of Zs, this Z1s.
Otherwise, we could have a different factor also in
obviously, we are making it equal to that inductor. Okay, thank you very much. We will stop here for today. We will continue with this in the next class.